Determine if a relation is a function. To do that, we first need to know a few things. So let's look at some definitions. First, a relation is simply a relationship between two sets, where each element of the first set corresponds with an element of the second set. We might show this in ordered pairs or in a graph. We have different ways to show and represent a relation. Now, within that relation, we have a domain, which is the first set. So if you think about a coordinate plane, that would be the x-axis, which then also means it would be the x in an ordered pair, right? The first piece of an ordered pair. That makes the range the y values, or the second set of the relation. The definition of a function is a relation where an element of the domain corresponds to exactly one element in the range. And you might be thinking, well, what does that mean? Well, let's look at it. Okay, so first we're going to start and we're going to have this mapped out already. So we're going to decide if this relation is a function. Now, the two pieces that we're looking at are people. We have Sarah, Jazz, Domingo, and Maribel. And then we have the number of siblings on the right, the second set. So the domain are the people. The range is the number of siblings. When it talks about each member of the first set goes to exactly one member of the second set, look at the, arrows coming out of the domain. Sarah has one sibling. Jazz has 0 siblings. Domingo has 2 siblings. Maribel has 0 siblings. Each one of these people only has one arrow coming out of it. That means each member of the domain goes to exactly one member of the range. So yes, this is a function. If you map it out like this, where the domain is on one side, the range is on the other, and you draw arrows, if the domain has just one arrow coming from each piece, then it is a function. Let's look at the next one. We have the school start time, 8, 9, and 10 a.m. on the left. That's the domain. And then we have the grade, 4th, 8th, freshman, and junior on the right as the range. Notice the domain. 8 a.m. goes to 8th grade. 9 a.m. goes to freshman and goes to junior year. So the domain of a piece of 9 a.m. goes to 2 different pieces in the range. Right there, we know this is not a function. Because remember, a function, each member of the domain can go to one member of the range, where here the 9 a.m. piece goes to 2 members of the second set. So it is not a function. Let's look at some ordered pairs. We want to determine if this relation, this set of ordered pairs, is a function. So we have the ordered pairs 4, 5, -2, 9, -1, 2, and 3, 0. Well, if you look at the domain 4, -2, -1, and 3, well, each one of those goes to exactly one member of the range. We know that because there are no repeated domain values. Sometimes it's helpful to draw it out. So if you list the domain values and you list the range values and you draw the arrows, then you can clearly see each member of the domain goes to exactly one member of the range. Therefore, yes, this is a function. Makes it a little nicer for you. What about this one? We have 4, -5, 2, 5, 4, 2, and 0, 0. Well, hopefully you notice right away that the domain value of 4 goes to -5 and 4 goes to 2. So because the domain value of 4 goes to 2 different values in the range, this is not a function. Again, sometimes it may be helpful to draw it out. If you do that, clearly you can see that the domain value of 4 has 2 arrows coming out of it, and therefore it is not a function.